So as you can see, we are going to start with a new topic, that is singly linked list. So we are going to discuss this topic in detail, try to understand the concept so that programmatically when you're implementing it, it becomes much more easy. As I always say, clear your concepts so that your programming would be easy for you. So let's try to dig down into the topic and try to understand what basically is singly linked list. So yes, we start with our first pointer for singly linked list, which says each element is stored as a node. Okay, now in singly linked list, again it is a data structure helping us to store our data, and to store that data we have concept of nodes. Okay, we have concept of node. So how is this node supposed to be represented? It looks something like this. Your node will look something like this, and your data would be stored inside your node. Your second point says your node would be represented with, or how your node is supposed to look like. It is going to consist of data and next. Okay, linked list. Now let's try to understand our node concept. I've already drawn a node for you. Your node would consist of data and next. Data would be any value that you want to insert, any value that you want to store. So data structure is basically storing data in a structured format. So your data part would come here. What is this next? This next is going to be a link. This node, this particular part is going to be a link to your next node. That's why we called it as linked list. A list which is linked to each other. So that's why your next will consist linked to your next node. So that is what your node. And this together is called as a node. Okay, node. Next point that you have is first node is always head. So whenever you create your node, now for us to work on linked list, we need to create this node. And your first node that you create is always going to be your head. Okay, first node created is always going to be head. With that, last node points to null. So wherever is your last node, now suppose this is my first node and this is my last node as well, right? This is the first node and this is only the last node for me. So that my last node would always be null. Okay, last node points to null. Points to your next, points to the next element that is there. So your last node will always point to null because there is no other node for it to be connected to. Let's try to understand this example only. Suppose you have 2 to 3 nodes that are linked. Okay, so this node is your last node. This part would be null. Why null? Because this node is not connected to any other node. This is the last node. Okay, so data next will store link for the next element that is there in the line. That is the concept. So your head and your last node will point to null. Okay, next you have is declaring of linked list. Now whenever we want to work on linked list, we have to create this, right? We need to create this particular node, and to create this particular node I will require a structure. Okay, let's try to understand this topic now. Why a structure? Now if you look at your node, your node consists of two things. One is data and one is next, like mixture of two things, right? So your data consists of value. That value can be what? Integer, character, float, data. Okay, your data would consist of value, and your next will consist of what? It is a pointer. So basically it is going to hold address of the next element that is there in line. So that is what your next is. So your next is a pointer. So these two things are different data types, right? These two things, data and next, are of different data types. So for me to create this structure, I'll need a data type which will represent this. So if you take array, what does array do? Same data type. Array stores data of same data type. There is one more concept as structure. What does it do? Different data type. So we already know the concept of array and structure. Array will store data of same data type and structure will store data of different data types. So in this case, the data type is going to be different. One may be, integer, character, float. The other is a pointer. Both are different. So for this, I will require a structure. So I have created a structure over here. Okay, now let's try to understand this structure. Now, if you look at your node, now to understand this structure, if you look at your node, there are two things, right? Data and next. So I need to declare this structure. That's why I'm declaring this. Okay, so in my structure name is linked list. You can give any name for your structure. And with that, I am declaring these two things. One is data, int data. Now, in this case, I'm trying to store integer type of data. If it was character, I would have said char data. Right? So here, whenever I'm trying to input my data, I'll give my data type. So here in this case, it is integer. So my one space for this is created. And the second second thing in my structure that I need is a pointer. Can you see this pointer? So it is going to be your next. This is your data. And this is your next. Right? Data next. So I need to create this structure. That's why I have declared this. Okay, I'm just telling that there has to be a structure, something like this created. Okay, you are just defining the structure of it, that this is how the structure should look like when I'm going to create it. Next point that you have is creating. So this is declaring and this is creating. Declaring is just telling that this kind of a structure is what I need, and creating is actually creating that node, actually allocating space to that node. So creating, let's try to understand create node. Now for this is the function where you say node create node. Okay, create node is my function which I will be calling in my program as and when I want to create this structure, this node. Okay, so what have I done? Node temp. So I am trying to create a node. I am trying to create a node which will be temp. Okay, node temp. So whenever I'm going to call this particular function, I'm going to create a node which will be called as temp. How am I going to allocate memory space to it? Temp equal to node malloc size of struct linked list. Now let's break this down. Okay, malloc is what? Dynamic allocation. This will do your dynamic allocation of memory. Dynamic memory allocation. Okay, so this function is basically used for your dynamic memory allocation. Now how does this work? I am trying to create a space dynamically, that is runtime, for this particular node which is named as temp. And what am I trying to do? Size of. Size of is again a function. Size of is a function that will runtime allocate size to that particular node. So in this case, what is my data? It is integer. So it will allocate memory space as per the data type. If it was character, it would allocate the memory as per the data type. So size of what? Struct linked list. Linked list. So I have declared this particular linked list, and then what I'm trying to do, I'm creating the node. Now for me to create the node, I'm trying to allocate the memory runtime. I don't create my nodes and keep. I will create my node as and when I require it. I'll create my nodes as and when I require it. So how will I create it? I'll have this function. I'll call the function from my program. This particular thing will allocate the memory to it. So one node will be created. That node will be called as temp. It will have data. It will have next. Okay. With that, temp of next equal to null. Now I already know, I have seen in my definitions over here that my first node is always head, and also the next is going to be what? Null. Why? Because when I'm creating the node, I would not know which node it is connected to. Is it my first node? Is it my last node? So whenever I create my node, I will create that structure and I will put this value as null. That means I'll not connect it to anyone. For me, I'm just creating my node. Okay, the linking will be done in later parts. So that is this line. Temp to next equal to null. And then I return my temp. Where it is going to return? Wherever I'm calling this create node function, it will return there. Once I return this, then I'll carry on my functions. My function would be what? Connecting different nodes, right? Putting the inserting data, deleting data, that would happen. Those would be my operations. Because as and when we go with the operations on linked list, these two functions will already be there. So please focus on these two parts. Also go through the concepts before starting the programming.